Okay, for the next few problems, we are not going to be given a function table. We're going to determine what function best describes the situation. And then we're going to write a model and possibly answer some questions. So here we go. Mandy and Addison are practicing for their softball tournament. Mandy pitches Addison the ball. Addison hits the ball from 3 feet off the ground with an initial velocity of 90 feet per second. What function best describes? So if you recall, when you have a velocity and you have something that's going up and coming back down, that indicates projectiles. So we will have a quadratic function. So let's recall, we're going to have an A, a B, and a C because we're talking about a quadratic function. With projectiles, our A is going to be our acceleration. And since we're talking about feet, we're going to use gravity of 32. And so remember, we have it and it's negative because our object is going up and then it's coming down. So negative 16 will be the A value. Our velocity is 90. That's our B value. Our velocity is our momentum. We're gaining speed. And then it starts 3 feet off the ground. So here we go. Here is our model. Negative 16x squared plus 90 times x plus 3. Now, x represents seconds, and our output represents height in feet. So let's answer some questions. Let's rewrite our problem. Negative 16x squared plus the velocity plus 3 where it was launched. The maximum height, that means we need the y value of the vertex. How long does it take to reach? We need the y part of our vertex. Okay, so we need the vertex for these two questions. And then how long will it hit the ground? How long will it land? We need our positive root, our x-intercept. So recall, negative b over 2a. This is our x value. This will be how many seconds it takes to reach the maximum height. Then we plug that into our function to get the actual height. So this is vertex formula. So the x part of our vertex, negative b over 2 times a, that's almost 3 seconds, but not quite. 90 divided by 32 gives us roughly, I'm just going to round it to the 10th. If you want to be more precise, 2.8125. Now let's plug this into our function. So 2.8 answers our second question. So how long does it take to reach the height? About 2.8 seconds. We're going to plug that into the function. And we're going to carefully input that into our calculator. And I get roughly, or actually, 129.56 feet. So we could say, let's just say 129.6 feet. Now, how many seconds will it take for the ball to land? We're going to use the quadratic formula. I think I might change pen color here. So we're going to have negative b. So my x value, negative b, or values, I should say, plus or minus b squared minus 4 times my a times my c, all over 2 times a. Simplify that a little bit more. Keeping your work nice and neat. So 90 squared is going to be 8100. Then I pause to determine, excuse me, the sign. So a negative times a negative is a positive. Now I no longer have to worry about the sign. So we're going to multiply those three factors and get 192. Again, I'm going to simplify and get a radical, my radicand, add those two values. 8100 plus 192 gives me 8292. So we're going to have one root we add, and we're going to have another root where we subtract. We know this ball started 3 feet off the ground at 0 seconds. So when I get the negative root, that root is irrelevant, does not pertain, is not realistic for our situation. So let's plug this in very carefully. Negative 90 minus the square root of 8292. I'm going to click enter, and then I'm going to say divide by negative 32. I get a positive, so about, this is about 5.658, blah, blah, blah. So let's just say, let's round to the 10th and say 5.7. Now look, this is positive. I already know the other root is going to be a negative, so I'm not going to go through that. You can if you want, but you can get a negative value and it will be irrelevant. So it takes about 5.7 seconds for Addison's ball to hit the ground. Parker is opening a tutor business. He charges $30 for his client just for showing up, and then he charges $40 each hour. So this tells me this is linear. So our model, our slope is $40 per hour plus your $30 initial fee. So my X represents hours, and F of X, total tutoring charge. Jackson and Kanan are starring in the Broadway musical Phantom of the Algebra. In their first production, there were 800 attendees. For the next several shows, they had a growth rate of 12% for each show. What type of function would best describe? We're going to go with exponential function because we have a growth rate of 12%. So let's talk about what we know here. The A value, the initial amount of people showing up to their show, is 800. Their B value is the growth factor. We have a growth rate of 0.12. However, we still have the 100% that attended the first showing. So our growth rate is 12%. Our growth factor is 1.12. Our model is 800, and our B value is 1.12 raised to the X. Now we're going to talk about what the X represents in our next slide. So our function, 800 people. After the first showing, it grows 12%. So let's talk about what the X represents. So when X equals 0, okay, you know that anytime you have an exponent that's 0, that gives you 1. So when X is 0, it gives us the total for our first show. We know was 800. So when X was 0, this was the total amount of people on the first show. So when X is 1, this is going to be the show after the original first. So this would be our second show. This reminds me of geometric sequences, actually. Then when our X value is 2, this is not our second show, this is our third show, but it's the second one once the rate started growing. So this is our third show. So we're going to get to when X is 3. This represents our fourth show. When X is 4, this is our fifth show. So you always just have to interpret exactly what's going on in your function and what it's asking, what the X represents, and what your F of X represents. So guess what? To know how many people are at the 6th show, we had to plug in 5 for X. We have our 800 in our first show. So X is going to represent the show after it started growing. Okay, so on the 6th show, our amount of people that have been coming has increased at a rate of 12% for the past 5 shows. Okay, so when we plug in, I should have plugged in a 5 here. Okay, so let's take our calculadora, 800 times 1.12 raised to the 5th for our 6th show. And that gives me roughly, whoopsie, I'm tracking a little bit, an 8, 7, blah, blah, blah. Now, we can't have a partial of a person, so let's just raise this to 1410. So in our 6th show, Kanan and Jackson had this many folks showing up to their amazing musical, Phantom of the Algebra. Lila and Ava bought a grand piano for $50,000 because the piano was rare. It appreciated in value at 8.5% each year. What type of function? So since again, we are having a rate, a percentage of increase, this is going to be exponential. So we have an A value. The original price of the piano is $50,000. And then it grew. So again, we're going to add an 8.5% means we have 1 and 2 decimals. So it's going to be 1.085. So make sure you move that decimal 2 places to the left when converting from percentage to a decimal. So let's write our function. So X is going to be the year. So in year 0, when they initially bought it, it was 50,000. So X is going to represent the value at the end of each year. $50,000 times 1.085 X at the end of the year in which they've had it. So we're just going to plug in 20. In our handy dandy calculadora times 1.085 raised to the 20. And wowzer. So they could use this to help pay for their kids' college, maybe. So let's run this as money. So I'll run that to a 1. So $255,602.31 in 20 years. Way to go, girls.